Now let's see what parametric functions are. Now, one thing you must remember here is that as your education advances, things become a bit more confusing, and this is one of those things. But it's not really confusing at all, honestly, once you learn what it is. Sometimes a curve is described by expressing both x and y as a function of a third variable, which can be anything, but in general we have t or theta, t being time and theta being an angle. So basically x and y change with respect to time or with respect to theta, the angle. And these two are called parameters. And the equation is of this type. Basically x is a function of time and y is also a function of time. And these are called the parametric equations of the curve. So both x and y are defined by a third variable, which is common to both x and y. In this case, it's time. So here's an example. X is equal to a into t squared. So x here acts as the dependent variable and t is the independent variable, and x is now a function of t. So basically x is equal to a function of t, which is equal to a t squared, right? Similarly here y is equal to a into t. So y is also a function of t, right? Now here's another example. X is equal to a into cosine of t. So x again is a function of t. Y is equal to a sine of t. So y is also a function of t. And as you progress further and further in your education, you'll encounter a lot of this, a lot. So be very clear about what it is. You'll not be able to see this t clearly because if you have an xy plane, the t is not there. So you must be careful. And remember that x and y in the cases are functions of a third variable that you're not seeing in front of you. Here you have x as a function of an angle, which is theta, and y is also a function of an angle theta. So they change with respect to the angle. So in here, well, again, the value of x changes with the value in theta, as x is a function of the angle theta. Same is the case for y. I hope that clears up what a parametric function is.